inferential statistics. Inferential statistics makes inferences about population using data drawn from the population. Instead of using the entire population to gather the data, the statistician will collect a sample or samples from the millions of residents and make inferences about the entire population using the example. As you can see, for the parametric test for correlation, there are 8 participants, and I had to work out the x squared, y squared, and xy simply by just squaring each x value to give me x squared, squaring each y value to give me y squared, and then just timesing the y value by the x value to give me the xy value. As you can see by the equation, there are different symbols. Each symbol means something. So the n means the number of participants. So the backwards the sort of E shape means the sum of. X means scores of the x variable, y means scores of the y variable. Then at the bottom you've got loads of different ones, a combination of them. So you have the E and the x squared, which means the sum of the raw scores for x squared, and then you have the E and the y squared for the sum of the raw scores of y squared. And then you have the same ones but in brackets, so the E and the x with the squared bracket would be the sum of all x squared. Then the E and the y in the brackets with the squared means sum of all y squared. So then I have 8 participants. I did all the calculations, giving me the results on the bottom. I then put all of those into the equation, which gave me 0.47. And because we have 8 participants, we minus the 2, which gives us the 6. We then go down to 6 on this table, then go along to 0.05 as it is the p-value, which then gives us the critical value of 0.7067. This tells us that it's not significant as well. There's no significant difference, sorry. By doing this is called the degrees of freedom. The rows in the significance level is 0.05, like I said before, and is the row where they meet in the table, which is the critical value. Using this and the calculated R value allows you to see if the testing was significant. If the R value is below the critical value, there is no significance. However, if it is above, there is. And because the critical value was below, there is no significant difference. Spearman's rank order test. So for this, I had to rank order all the points scored for both. Then I had to work out the rank difference between D and the difference between the rank squared. This then gave me the values below. Then I was able to transfer into the equation, which is on the slide, which then gave me the value of 0.74. And because there were 10 participants within this, we minus 2, which gives us 8. So we then go down to 8 on the table, then go along to 0.05, which gives us the critical value of 0.74. And because we know the calculated R value is 0.4, it shows that there is a significant difference. So the independent t-test, all I had to do was work out the mean and the standard deviation for these, so it was quite easy. So by doing this, I then put it into the equation, and thereby doing this, I got the t value of 1.31. So, and because for this one it was a little bit different, rather than just doing n minus whatever number it was, for this one you had to do the number of participants in group 1 plus the number of participants in group 2 minus 2, which gave us 18. So then you'd go down to 18 on the table, then go along to 0.05, which gives us a critical value of 2.101, which tells us that there is a significant difference. So then we have the dependency test. I had to work out for the difference and difference squared, which was quite easy. So you just did the higher value minus the lower value, which was post-training minus pre-training jump, which gave us the difference, and the difference was just to square that for the difference squared. Then I was able to get the values below underneath the other ones. I then put this into the test. I was then able to put this into the equation, which then gave me the value of 3.2. And for this one, it was similar to the others, where you have n minus 2, so the number of participants, which was 6. It's n minus 1, sorry, there's a mistake on the slides, which gives us 5. So then go down to the number of participants, which was 5, then go along to 0.05, which gave us 2.015. There's a mistake on the slide, which tells us there is a significant difference.